Hi, this video is a continuation of the previous video on center of mass or center of centroid of the thin plate or a lamina. We did already one example. This is another example for centroid. Find the centroid of the region bounded by the curves cosine x, y equal to cosine x, y equal to 0, x equal to 0 and x equal to pi by 2. So we know that we will graph this to get a better idea of the lamina. So it is cosine x is the curve. Then cosine x, if you do the entire graph, it's going to look like a tongue-shaped graph. This is 0 and this is pi by 2 and pi, this is 3 pi by 2 and the last point is 2 pi. Now we are interested only in that part of the graph which goes up to pi by 2 because it says x equal to 0 to x equal to pi by 2. So x equal to pi by 2. This is the graph cosine x. Then it's bounded by y equal to 0 which is the x-axis and then x equal to 0 which is the y-axis and x equal to pi by 2. We are going to find out the center of mass which is x bar and y bar. So let's first find out A, which is equal to the area of the thin lamina, which is equal to integral a to b fx dx. In this case, it is integral 0 to pi by 2 cosine x dx, which is sin x between the limit 0 and pi by 2, which is sin pi by 2 minus sin 0, which is equal to 1. Sin 0 is 0, sin pi by 2 is 1. So area of the plate equal to 1. Next, let's find out x bar, which is the x coordinate of the centroid, which is 1 over a integral 0 through pi by 2 x f of x dx, which is 1 over a, which is 1 over 1 in this case, integral 0 to pi by 2 x times cosine x dx. This part you are going to do u dv method, integration by parts. This is u and this one is going to be dv. This one is dv. So if you apply that integration by parts, it is u times v minus integral of cosine x is sin x, so that will become v. So this is u, this is v minus integral v du, which is equal to dx in 0 and pi by 2. The x cosine x times sin x that also should be evaluated between 0 and pi by 2. So it is pi by 2 times sin pi by 2, which is 1. And then the lower limit it is 0. Integral of sin x is negative cosine x. That will make it negative, that becomes positive. 0 to pi by 2. So cosine pi by 2. So it's going to be pi by 2. Then cosine pi by 2 is going to be 0 minus cosine 0, which is equal to 1. So it is pi by 2 minus 1. So x coordinate of the centroid is pi by 2 minus 1. Then the y coordinate of the centroid, by the formula, it is equal to 1 over a integral 0 through pi by 2 1 half f of x square dx. So it's 1 over 2a, a equal to 1 anyways, 0 to pi by 2 f of x square, so which is cosine square x dx. So a equal to 1, which we evaluated before. So it is 1 over 2 integral 0 to pi by 2. Being a square, we have to use the double angle 1 plus cosine 2x over 2 dx. Now it is 1/4 outside, 1/2 again can be pulled out. If you integrate, it is x plus sine of 2x over 2 between the limit 0 and pi by 2, which is 1/4 pi by 2 plus sine 2 times pi by 2, that will be sine pi, which will be 0. The lower limit, it is equal to 0, so it is pi over 8. So y component of the centroid is pi over 8. So the centroid, it should be written in terms of x coordinate and the y coordinate. X coordinate is pi by 2 minus 1. The y coordinate is pi over 8. If the region R lies between two curves, y equal to f of x and y equal to g of x, where one of the curves is more than the other curve. If f of x is more than or equal to g of x, as shown in this figure, then the same set of argument that led to the previous formula, can be extended here for centroid. So there it was 1 over a integral x times f of x. Now we are going to modify that and write it's 1 over a integral a to b x times f of x minus g of x dx. The other one, 1 over a, the y coordinate, integral a to b, half of f of x square minus g of x square dx. If the region is made up of only one curve, we will have just f of x. If the region is made up of two curves, we will have f of x minus g of x multiplied by x for x coordinate. Then square of f of x minus square of g of x times half, then outside 1 over a will be the y coordinate of the centroid. So find the centroid of the region bounded by the line y equal to x and the parabola y equal to x squared. So now we have two curves. The top one is y equal to x and the bottom one is y equal to x square. And the region occupies, the region is between these two curves. Now let's first find out the area between the two curves, which is integral a to b, top curve minus the bottom curve, y top minus y bottom, d of x, which is integral 0 to 1. The two curves meet between 0 and 1. If they don't give that information, actually we can set the two y's to be equal, x minus x square equal to 0, then x times 1 minus x equal to 0, which would give us x equal to 0 and x equal to 1. We can actually find out the points of intersection of the two. Now let's do x bar, which is the x coordinate, which is equal to 1 over a integral x times the top curve is x, minus the bottom curve, which is x square dx. So it's x, y top minus y bottom. So this is y top, this is y bottom. And we have to multiply by x dx. So that will be 1 over a. So we will substitute this a 1 over 6 at the end of the problem. This integral, wherever the two curves meet, which are between 0 and 1, x times, if you distribute the inside, it's going to be x square minus x cube dx. And outside we have 1 over 1/6, which will become 6. We are going to integrate, which is x cube over 3 minus x to the power 4 over 4. So it is 6 times 1/3 minus 1/4. And this will be 4 minus 3, which will be 1 over 12, or which is 1/2. So x bar is going to be just 1/2. Let's find out y bar, which is 1 over a integral a to b, where the two curves meet. Then it's half of f of x square, the y top square, minus f of x square minus f of y square. That is 1 over 2a, then integral 0 to 1, f of x square, which is the top curve square, so x square, minus the bottom is x square, and you have to consider the square of that x square, so it's x to the power 4 d of x. That is 1 over 2a, and it's x cube over 3 minus x to the power 5 over 5, which is 1 over 2a times 1/3 between the limit 0 and 1. It's 1/3 minus 1/5. So it is 1 over 2 times 1 over 6. Then this will be 5 minus 3, which is 2 over 15. So that will be, if you reduce this, simplify, it's 1 over 1/3, which will be 3 times 2 over 15. 3 goes into 15 5 times. So it is 3, it is going to be 2 over 5. So the x coordinate, the center of mass, the centroid in this case is x bar y bar. X bar is 1/2, the y bar is 2/5. Hope this video helps.